About 74,000 years ago, a volcano on the island of Sumatra blew itself apart. It was one of the largest eruptions in millions of years. Ash buried whole regions, the sky may have darkened for years, and for a long time scientists told a chilling story about what it did to us. They said it nearly wiped out the human race, that our entire species was cut down to a few thousand survivors. It became one of the most famous ideas in human prehistory. There's just one problem: it might not be true. The place is Lake Toba, in northern Sumatra in what is now Indonesia. Today, it is a vast, beautiful lake, dozens of miles long, with an island in the middle. But that lake is a scar. It is the crater, the caldera, left behind when the volcano beneath it erupted with almost unimaginable force. The peaceful water sits in the wound of one of the most violent events in the planet's recent history. The numbers are staggering. The Toba eruption was a super eruption, the highest level on the scale of volcanic blasts. It threw out something like 2,800 cubic kilometers of ash and rock. To put that in perspective, it dwarfs every eruption in recorded human memory. The famous blast of Krakatoa or the eruption of Mount Pinatubo are tiny by comparison. Toba was in a different league entirely, the kind of eruption that happens only once in tens of thousands of years. The ash spread across an enormous area. A layer of Toba ash has been found across India, in the seafloor of the Indian Ocean, and far beyond, thousands of miles from the volcano, in places that ash settled meters deep. For a brief, terrible window, this single eruption reached across much of the world, raining gray dust onto distant lands. So it is natural to ask what such a blast did to the living world and to us. And in 1998, a scientist named Stanley Ambrose put forward a dramatic answer. He proposed what became known as the Toba catastrophe theory. The eruption, he argued, hurled so much material into the sky that it blocked the sun, plunging the Earth into a volcanic winter that lasted years. Temperatures crashed, plants died, and the early humans of the world, caught in this sudden global freeze, starved and died in vast numbers. According to the theory, our species came terrifyingly close to the end. It claimed that humanity was reduced to perhaps just a few thousand individuals, a tiny, scattered, struggling remnant. We supposedly squeezed through a narrow bottleneck, a near extinction so severe that it left its mark on our very DNA. The idea was that every person alive today descends from those few survivors of the Toba winter. It is a gripping story. It explained, in one stroke, why humans have surprisingly little genetic diversity compared to many other species. It gave our origins a dramatic near-death moment, a single catastrophe we barely lived through. For years, it appeared in documentaries and textbooks. It felt true. And that is exactly why we have to be careful, because a story feeling true is not the same as a story being true. If a hard look at a famous theory is the kind of thing you came here for, take a moment now and subscribe to Kindred. We follow the evidence wherever it leads, even when it spoils a good scary story. And stay close, because over the last 2 decades, the Toba catastrophe theory has been quietly falling apart. The first cracks came from the ground itself. In southern India, at a site called Jwalapuram, archaeologists found stone tools both below the Toba ash layer and above it, the same kinds of tools made in the same ways before and after the eruption. If the people there had been wiped out by a years-long volcanic winter, you would expect their tools to vanish from the record. Instead, the toolmakers seem to have carried on, right through the disaster. Whoever they were, they did not die out. They kept living and kept making their tools on top of the very ash that was supposed to have killed them. Then came the climate evidence. Scientists drilled deep cores from the bottom of Lake Malawi in East Africa, far from Sumatra. These cores hold a detailed record of the local environment stretching back across the time of the eruption. If Toba had caused a brutal global winter, you would expect to see it written there, a sudden collapse in the plants and life of the region. But the cores show no such collapse around the time of Toba. The East African environment, where many of our ancestors lived, seems to have rolled on without a catastrophe. The climate models came under fire too. The original theory leaned on estimates of how much sulfur the eruption pumped into the sky and how badly that would cool the planet. Newer, more careful modeling suggests those early estimates were far too high by a large margin. The volcanic winter, in the latest models, looks much milder and shorter than the catastrophe theory required. A bad few years, perhaps, not a planet-freezing apocalypse. And then there is the DNA, which was supposed to be the smoking gun. Modern genetics can search our genomes for the fingerprints of ancient population crashes, and when scientists look, they do not find a clear, sharp bottleneck right at 74,000 years ago. Our species does seem to have passed through periods of low numbers at various points in the deep past, but the dates do not line up neatly with Toba, and some of those dips can be explained in other ways. The genetic proof that was supposed to anchor the whole theory simply is not there in the way it was once claimed. To picture the eruption, look at Lake Toba itself. It is about 100 kilometers long, one of the largest volcanic lakes on Earth, and in the middle sits a large island slowly being pushed up from below as pressure builds again beneath the surface. The whole serene scene is the throat of a sleeping monster. When it last fully erupted, it did not just pour out lava. It collapsed, emptying a colossal magma chamber and dropping the ground into the void to form the giant basin the lake now fills. The reach of the ash is genuinely hard to imagine. The Toba eruption laid down a layer of volcanic debris across much of South Asia, detectable from India to the bottom of distant seas. In some places, that ash bed is meters thick, even today, tens of thousands of years later. For a time, the eruption touched a huge slice of the planet, dimming skies and dusting forests thousands of miles from Sumatra. It is fair to ask what an eruption like that could do to the climate, and we have smaller modern examples to learn from. In 1815, a volcano called Tambora, also in Indonesia, erupted and threw enough material into the sky to cool the whole planet noticeably. The next year became known as the year without a summer, with failed harvests and strange weather across the world. And Tambora was far smaller than Toba, so the instinct that Toba might have chilled the Earth is not crazy. The question is how badly, and for how long. That is where the catastrophe theory took its leap. It assumed the cooling was extreme and long, a true volcanic winter lasting years, severe enough to collapse food supplies across whole continents and push humanity to the brink. It was a bold extrapolation from the raw size of the eruption, and because it was dramatic and because it tidily explained our low genetic diversity, it caught on fast and held on hard. But careful science has chipped away at almost every part of that leap. The Indian tools at Jwalapuram suggest local people lived through the event. Critics have argued back and forth about exactly what those tools mean, and the debate there is real and ongoing, but it is one of several independent challenges, not a lone objection. When tools, lake cores, climate models, and genomes all point away from catastrophe, the weight starts to shift. The genetics deserve a closer look because they were the theory's foundation. It is true that humans have low genetic diversity, which can be a sign of past population crashes. But low diversity can also come from a founder effect, when a small group splits off and seeds a new population without any disaster at all. And when geneticists hunt for the timing of our ancient bottlenecks, the strongest signals do not land neatly on Toba. They scatter to other periods entirely. The DNA does not point its finger at the volcano. There is a broader lesson here about how science handles a thrilling idea. A single dramatic cause is seductive. One volcano, one terrible winter, one near-death escape. It makes a perfect story, easy to remember and easy to tell. But nature is rarely that tidy. The more researchers looked, the more the neat tale frayed, until what was left was a real and enormous eruption, and a much shakier claim about what it did to us. None of this means our ancestors had it easy. The deep human past was genuinely dangerous. Populations were small, climate swung wildly. Disease, famine, and bad luck could erase a band of people. Our species really does carry the marks of having been few and fragile at times. The fragility is real. What is doubtful is the idea that one volcano on one day was the great near ending of it all. It is also worth being fair to the original theory. When Stanley Ambrose proposed it in 1998, it was a creative, testable idea that fit what was known at the time. That is exactly what good science is supposed to produce, bold proposals that can be checked. The theory's job was to be tested, and it was rigorously for decades. That it has not held up is not an embarrassment. It is the process working as intended, and the door is not fully closed. Science rarely deals in absolute certainty. New evidence could always shift the picture again, revealing some regional impact, some population that did suffer, some thread the current view has missed. That is why the honest word is debated. Not disproven beyond all doubt, and certainly not proven. Held in question, with the evidence leaning one way. So where does that leave us? It is important to be precise and honest here. The eruption itself is absolutely real. Toba was a genuine monster, one of the greatest volcanic events in the story of the Earth. That part is not in doubt. What is in doubt, and increasingly so, is the claim that it nearly drove humanity extinct. That specific idea, the near extinction, the bottleneck, the handful of survivors, is debated. It is not proven. And the weight of recent evidence has been pushing against it. This is not a failure of science. It is science working exactly as it should. A bold, dramatic idea was proposed. It was tested hard from many directions with tools that did not even exist when it was first suggested. And as the evidence came in, the idea began to give way. The scientists who challenged the catastrophe theory were not ruining a good story. They were doing their job, refusing to let a gripping tale stand in for the truth. There is still a real and humbling fact underneath all of this. Our species does carry signs of having been, at times, surprisingly few in number. Compared to many animals, humans are strikingly similar to one another in our DNA, which hints that our ancestors passed through tight spots, low points where the whole population was small and fragile. We really were, for long stretches, a vulnerable species clinging on. But pinning that fragility on one volcano, on one terrible year, now looks like too simple a story. Maybe that is the deeper lesson of Toba. We love a single dramatic cause, one disaster that explains everything. The real history of our survival was probably messier and slower, a long story of small populations enduring many hardships across thousands of years, not one near-death escape from a single volcano. The truth is less cinematic, but it is more honest, and in its own way just as remarkable. So, did we almost go extinct 74,000 years ago when Toba erupted? The honest answer is that we are not sure, and the evidence increasingly says probably not, at least not because of the volcano. The eruption was real and enormous. Its power to nearly end us is a story that science is steadily taking apart. The question is still open, and that openness is exactly the point. If you want to keep weighing the real evidence about our deep past with me, Kindred is just getting started. I will see you in the next one.